In this video, bubble sort algorithm will be discussed. So bubble sort algorithm is the simplest sorting algorithm that repeatedly steps through the list, compares adjacent element and swaps them if they are in the wrong order. So basically this algorithm works by repeatedly swapping the adjacent elements if they are in the wrong order. So this process continues until the list is completely sorted. This bubble sort algorithm is not suitable for large data sets as its average case and worst case time complexity is high. Let's see one example. So let's solve it. Before we solve this example, like I just want to discuss few steps like how the bubble sort will be applied on this example to sort the array of elements. So basically in the bubble sort we'll be using two loops. First loop would start from 0, I equals to 0, I less than n, I plus plus. This is our first loop. This loop is for the passes, how many number of passes our algorithm is going to take, the iterations. So inside this for another for loop is there, j loop. J should start from 0 all the time and it would iterate till n minus I and j plus plus. So mainly there are two loops in bubble sort algorithm, and every time, as I discussed before, every time it would compare with the adjacent element and swap it if it is in the wrong order. So every time you would be comparing array of j element along with array of j plus 1. So only if array of j is greater than array of j plus 1, we are supposed to swap array of j and array of j plus 1. So we are going to continue this process until the list is completely sorted. So only these two steps we are going to follow here. So mainly these two steps we are going to keep on continuously compare the elements, the adjacent elements, and we will swap it only when the array of j is greater than array of j plus 1. So here according to the algorithm, so according to the pseudocode mentioned here in the bubble sort, after the first pass, for example if there are n number of elements, if you take the current example, there is an array with n number of elements. So here the n value is 5, which means there are 5 elements are there, right? So if there are n number of elements, our bubble sort algorithm is going to take n minus 1 number of passes. So here the number of elements, the n value is 5 here. So the algorithm is going, for this example the pseudocode is going to take only n minus 1 number of passes, which means only 4 passes it is going to take. Let's solve the example. So every time at first pass, at the end of the first pass, the largest element will be at the end, which means the largest element among all the elements, out of all the elements will be will be moved on to the end, which means the largest element will move on to the right position after the first pass, and after the second pass the second largest element will be in its correct position, which means the second largest element will be coming to the before last position in an array. So every time, so since the largest elements came to the right position, during the second pass we can, if you iterate before the last position, it would be enough. So that's why we have given the condition here as j lesser than n minus I. So every time, like in each and every pass, once the elements are sorted, in the upcoming passes we would be ignoring the elements which are already sorted, we would be ignored here according to the bubble sort algorithm. So let's start solving the example. So pass 1. So during pass 1 our I value is going to be 0 here. Our I value is going to be 0. Now go to the for j loop. So j starts from 0, it would keep on iterating it till n minus I. So here n value is 5 minus I value is 0, which means till 5, which means j lesser than 5, which means till 4 it would the j loop would get executed. So when j is equals to 0, write the example, copy down the example again, 55, 32, 89, 24, 10. So now when j equals to 0, check whether j is lesser than n minus I. Yes, j is lesser than n minus I. Like go inside the for loop, there are two statements given. The very first one is compare array of j and array of j plus 1. If array of j, this is our j and this is our j plus 1. Compare j and j plus 1 only if array of j is greater than array of j plus 1. We are supposed to perform sorting here. So yes, it is greater. Array of j is greater than array of j plus 1. So swap array of j and j plus 1. So if you swap, 32 would come here and 55 would go there. So after performing the swapping operation according to the loop specified here, we are supposed to increment our j pointer. So now j would be pointing this, and in the next iteration this 89 is going to act as j plus 1. They keep on, you just check it out, array of j and j plus 1. Only if array of j is greater, you are supposed to perform the swapping operation, otherwise you can simply increment the j. So now compare j and j plus 1, j is not greater than j plus 1. So if you cannot perform the swapping operation, simply increment j. So now j would come here and j plus 1 would go there. Compare again j and j plus 1. Yes, array of j is greater than array of j plus 1. So perform swapping operation. So in the next step, 24 would come here and 89 would go there, and then 8. After performing the swapping operation, we are supposed to increment j. So j was here, now increment your j, j would be pointing here now. And now this is j and this is j plus 1. So compare j and j plus 1. Yes, again j is greater than j plus 1 only. We are supposed to perform swapping operation between j and j plus 1. So 32, 55, 24. So swap 89 and 10. So 10 would come here and 89 would go there, and increment your j. So compare again j and j plus 1. So there is no j plus 1, and also the limit given here is j is lesser than 5, which means until j is lesser than 4 it would work. So it would come out of the loop. Now if you check, the pass 1 is completely over. At the end of the pass 1, if you check, the last element would have come to the right position, which means the one element is sorted here. The largest element is in the right position. So for pass 2, during the pass 2, if you concentrate on only these elements, it would be enough. So that's why we are giving the condition here, j is lesser than n minus I. So during pass 2, let's discuss pass 2 now, you will understand. During pass 2, like I value would get incremented to 1 now. So when your I value is 1, j is going to start from 0, and j would iterate till n minus I. N value is 5 and I value is 1 now. So 5 minus 1, which is 4. So j is less than 4, which means till third position it would iterate. Why? Because in the fourth position we have already we have right element in the fourth position. So in the upcoming iterations, if you concentrate only till the third index, it would be enough. So now, and 89, which is already in the right position, so we are supposed to concentrate on only these 4 elements. This is our j, and next is going to be j plus 1. Compare j and j plus 1. No, j is not greater than j plus 1, so you no need to perform swapping. So simply increment j. So now j is here. Compare j and j plus 1. Yes, j is greater than j plus 1. So you are supposed to perform swapping operation between j and j plus 1. So once perform the swapping, you are supposed to increment your j. So now j would be pointing the second index. Compare j and j plus 1 again. Again, yes, j is greater than j plus 1. Perform swapping now. So 32, 24, j and j plus 1, j is greater, so perform swapping 10 and 55. After swapping, you are supposed to increment your j to the next position. Now this is j and there is no j plus 1 because your list would stop over here. Till here, and also the condition given is until the j is lesser than 4, which means till 3 only it would get iterated. So the pass 2 is again completely over. At the end of the pass 2, like the second largest element will come to its right position. During the pass 1, the first largest element came to the right position. Now at the end of pass 2, the second largest element also would come to the right position. At the end of pass 3, the third largest element would come to the right position. So now at the end of pass 3, the third largest element would come to its right position. So we are supposed to proceed from this list only. So 59 and 89 is already sorted. So now the pass 3 would work till the index 2. So increment the I value. Now I value would be 2. So j would start from 0 and it would iterate till 5 minus 2, which means 3. So j is lesser than 3 means till second index only it would iterate. Yes, till second index only it would iterate. So now check, this is a j pointer. Compare j and j plus 1 whether j is greater. Yes, j is greater than j plus 1. So perform swapping. So I am swapping j and j plus 1. So 24 would come here and 32 would go there, and increment your j. Yes, incremented, and you no need to concentrate on these two elements because these two are already in the correct position, placed in the correct position. So now again compare j and j plus 1. Yes, j is greater than j plus 1. This is j and this is j plus 1, this is greater than j plus 1. So perform swapping again in the next step. So 10 would come here and 32 would go there, and again 55 and 89 which are already in the correct places. Now increment j. So now there is j but there is no j plus 1, so the pass 3 would get over now. Now if you check, the third largest element came to its right position, 32. So in the upcoming iteration again it would concentrate till the index 1 only. So during pass 4, this is our current array status, 32, 15, 5 and 89. So now if you check, these three elements are in the right position. Now this is going to be our j and this is j plus 1. Compare j and j plus 1. Yes, j is again greater than j plus 1. Perform swapping between j and j plus 1. So 10 would come here and 24 would go there, and once performed swapping, we are supposed to increment our j value. Again you start comparing it with the adjacent element. Yes, j got incremented now, but there is no adjacent element because this is going to be the last element in the list. So pass 4 also would get over. Now if you check, the fourth largest element also has come to its right position. And if you check pass 5, it can't go to pass 5, right? Because if you check, there is only one element in an array, so the bubble sort algorithm doesn't work here. So if you check totally how many number of passes it has taken, pass 1, pass 2, pass 3 and pass 4, which means 4 passes it has taken totally. If you check the n value, like the number of elements, the number of elements of 5. So if the number of elements of 5, the bubble sort algorithm is going to take only n minus 1 number of passes. So this is how the bubble sort algorithm works here. Now let's discuss the pseudocode. So pseudocode I have already explained here roughly, already I have explained the step by step here. So now we'll see the proper pseudocode. So there is a list given, algorithm bubble sort, the array given, and if you check, there are two loops here. One is I loop and another one is a j loop. So this I loop is for to indicate the number of passes, and this is for inside each and every passes, like it would be taking n minus I number of iterations it would be taking. So inside the j loop again there are two main statements given here. These are the two main steps we are performing in the bubble sort. Every time we are comparing each value with its adjacent element. If it is not in the right order, we are performing the swapping operation between array of j and array of j plus 1. This is what we are doing for the entire iteration. The same procedure, the same process continues until the complete list is sorted. So this is how the bubble sort algorithm works. So now if you check for the time complexity, so when we perform time complexity analysis, the worst case time complexity of bubble sort is going to be big O of n square. Let me tell you how. The worst case scenario is if the element is sorted in the reverse order. The scenario is going to be if the array is the elements in an array is sorted in so you want to sort it in the ascending order, but the input array is in a descending order. That is going to be the worst case scenario. It is going to take maximum number of iterations, which is n square, and best case is going to be omega of n, and the scenario is if the input list is already sorted, if the array is already sorted, and average case is theta of n square. Let's see how n square and how n we are getting under the best case and n square under the worst case. So if you check here, if you check the for loop is totally going to get iterated for only n number of times. For example, okay, when your I value is equal to 0, this is your I loop and this is your j loop. When your I value is equal to 0, your j loop would get executed for n minus I, right? So here the n value is 5. our input has totally 5 elements in an array, so our n value is 5. So when I value 0, our j loop would get executed for 5 minus 0 number of iterations, which is 5, right. When I values 1, our j loop would get executed for 5 minus 1 number of iterations, which is 4. When again I values 2, again 5 minus I is 2, 5 it is I is 2, so 5 minus 2, which is 3. When I values 3, the j loop would get executed for 2 times. When I values 4, j loop would get executed for only 1 time. So if you check this series, like when it is 4 it is 1, when it is 3 it is 2, when it is 2 it is 3, when it is 1 it is 4, so it goes on like this. So this indicates sum of n natural numbers formula. The formula is n into n plus 1 by 2. If you solve this, you would be getting the complexity, you would be getting the value n square. So the worst case complexity here is big O of n square. Otherwise we could take in this sense also, like this is what, this is n, the phi is what, n value is 5, so this is n, and this is n minus 1, this is n minus 2, this is n minus 3, and this is going to be n minus 4. So again the formula is n plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 4. So sum of n minus 1 numbers only it is going to be. Again the formula is going to be n into n plus 1 by 2. So finally when you derive this, you would be getting n square. So the worst case time complexity is n square. So the scenario is if the elements are the worst case scenario is if the elements are given in the sorted in reverse order. Sorry, if the elements are sorted in reverse order, which means, as I mentioned before, if the input elements already, like you want to sort it in the descending order, but the given input array is in the ascending order. So this is going to be the worst case scenario. So for all the passes, the j loop would get executed for all the times. Like it would be making the swapping operation, it would be performing the swapping operation for all n number of times, every n minus I number of times. So the complexity is going to be n square. So the best case scenario is the list is already sorted. When the list is already sorted, only this for loop would get executed, and we won't be performing any of the swapping operations. Only for the loop it is going to take a number of iterations, but swapping operations we won't be performing. Why? Because it's already in the sorted order, so the swapping operation is not required over here. So it would be taking only n number of iterations when it comes to the best case scenario. So that's it. So this is how the bubble sort algorithm works here, and please try this exercise problem. (23, 42, 75, 8, 6 and 9. So apply bubble sort algorithm on these elements and sort this out. Thank you.